Hello guys, welcome to another video. This one is paper 2-2 of May-June 2019. So let's move on to question number 1. So here we have to, given that y is given by this fraction, find the expression for dy by dx. So as you can see, you have a fraction here, so you have to use your quotient rule for dy by dx. So dy by dx is equal to, so first you have to write this one down, ln, the denominator, times d by dx of sine x. So d by dx of sine x. Then we have to write minus. Then we have to write sine x, the numerator, times d by dx of the denominator. And next step is to take everything, divide by, square the base. So you will have square. Now we just have to simplify. So ln x squared is the same. This will become cos x minus sine x times 1 over x squared times 2x. And all this divided by ln x squared power 2 square, right? So this one will cancel out and you will have cos x ln x squared minus 2 sine x over x and everything divided by ln x squared square. Okay, so that will be your answer for this expression of dy by dx. Okay, that is question number 1. Now, question number 2 is to find the values of k for which this equation has real and distinct roots. So when you see that, you know you have to use b squared minus 4ac is more than 0. So let's find the values. So a is k minus 1, b is k, and c is minus k. So we have to find b squared minus 4ac. So b squared is k squared minus 4 times a, which is this one, and c is minus k. So we have to simplify. You will have k squared. So here you will have minus, that will be plus 4k times k minus 1 more than 0. Simplify k squared plus, so we have 4k squared minus 4k is more than 0. Now we have to simplify. You will have 5k squared minus 4k is more than 0. Now we can factorize. You will have k outside, 5k minus 4 is more than 0. So now we have to find the critical values. So critical values is when this is equal to 0. So this is equal to 0. So k is equal to 0 and k is equal to 4 over 5. Now we have to draw a small graph to represent this curve. As you can see, this is positive. You will have to be in this shape. This is your first point 0 and this is your point 4 for 5. So we need this to be above this line. Above has to be on this side or on this side. So your values of k can be less than 0 and k can be more than 4 over 5. So this is your set of values of k that satisfy this condition, this expression. And that is your question number 2. Now question number 3, we have given that x is a factor of this, use the factor theorem to show that this. Pretty easy. So let's find the value of x. So we have to equate to 0. So x is equal to 2. Now for x is equal to 2, this is basically becomes 0 because it is a factor. So basically we can do is let f of x is equal to this expression, ax cubed minus 12x squared plus 5x plus 6. Now f of 2 is supposed to give you 0. Let's replace those values. You will have a, that will be 8 minus 12 times 4 plus 10 plus 6 is 0. Now this is 8a minus 48 plus 16 is 0. So 8a is equal to 32. a will be 4. This is shown as required for the value of a. That is part 1. Now part 2 is we have to factorize this whole expression and hence solve this. So how would you factorize that? You have to perform long division. So here you have this minus 12 x squared plus 5x plus 6. And we know that x minus 2 is a factor. It is given to you in part 1. So we can use this to find the other factor of this expression. So first question is, how can you make x become 4x cubed? You have to multiply by 4 and x squared. That will become 4x cubed minus 8x squared. So we have to minus minus, so this one cancel out. Now minus 12 minus minus is plus, so minus 12 plus 8, that should be minus 4 plus 5x plus 6. So now, how can you make x become minus 4x squared? You have to multiply by minus 4x. That will be minus 4x squared plus 8x. Now these two cancel out, then we have 5 minus 8 will be minus 3x plus 6. Now we can simplify again. How can you make x become minus 3x? You have to multiply by minus 3. That will become minus 3x plus 6. And this is supposed to give you 0. So in that case, this will be your two factors, which is f of x is equal to x minus 2, and then 4x squared minus 4x minus 3. So now we have to solve this equation. So equate that to 0. So first is x minus 2 is equal to 0. So x is equal to 2. Now we have 4x squared minus 4x minus 3 is equal to 0. Now we have to factorize this. So 4x squared is 2x times 2x. 3 is 3 times 1. Now to get minus 4, we have to have minus 6 plus 2. So x is equal to minus half and x is equal to 3 over 2. So your values for x will be x is equal to minus half, 3 over 2, and the value of 2. That will be your question number 3. Now let's move on to question number 4. A circle has a diameter, so you know diameter is equal to x. So what do you know about radius? As you know, radius is always diameter divided by 2, which is x divided by 2. That is your radius. Okay, that is good to know. Now, the diameter x is increasing at the rate of this one. So basically we have dx by dt. The rate of increase is 0.01. This is given to you. Now, question is, find the exact rate of change of the area of circle when x is equal to this. So, what is area of circle? So you must know the formula is pi r squared. So area is equal to pi r squared. And your question is to find the exact rate of change of area. So we have to find dA by dt. Now, so how would you find dA by dt? So we write down the equation. dA by dt is equal to, so on top you have dA, let's write down dA, multiply. At the bottom you have dt, let's write dt. Now what connects these two? As you can see, dt is connected, dA is connected to dt by dx. So dx and dx. So this is how we can find this one. So this is given to us already as 0.01. So we have to find this one, dA by dx. So here we have a problem because here we have r. So we have to change r to x. As you can see, r is equal to x over 2. Replace a will be pi x over 2 square, which is pi x squared over 4. So we have a is equal to pi x square over 4. Now we have to find dA by dx, so pretty easy. dA by dx is equal to 2x over 4. Now for this value, we have to find at x equal to 6. So replace that in your equation. So we have to find dA by dx at x equal to 6. That'll be 2 pi, 6, 4. That'll be 1, 2, that'll be 3. That'll be 3 pi for the value. So now since we have everything that we need, we can just replace back in your equation. So dA by dt is equal to dA by dx is 3 pi times dx by dt is 0.01. So your answer will be 0.03 pi. That will be centimeter square per second. That is the unit of area, and that is the rate of change that we need to show. That is your question number 4. So the main point here you have to do is you have to understand that diameter is 2 times radius, so radius is half of diameter. So that's the first equation. And then we have to know the formula for area, and then replace the value of r by this. You will have this, and then you can just find this pretty easily. Okay, that will be question number 4. Now for question number 5, we have to express this in terms of this. So let's see how can we do this. Always step by step. So the first thing I like to do is I like to write 5x squared minus 15x. I like to leave some space, right, plus 1. Now I like to factorize those two. So we take out 5. You will have x squared minus 3x plus 1. Now we can square this one. You will have x squared minus 3x. We have to plus something. So you will plus this number here, which is 3, divided by 2 square. Now when you plus something, you also have to minus the same value. So minus 3 over 2 square. Now since this was inside this bracket, you also have to give it a 5. Okay, so now we can simplify. We have 5 outside. This is x, and this is minus, and this is what? 1.5. And we have square plus, what does this one become? So let's see. 5 times 3 over 2 square. 1 minus answer should be minus 10.25, right? So let's try again just to be sure. So we have 3 divided by 2 square times 5, 1 minus answer, minus 10.25. So as you can see, this is in this form where P, Q, and R are constants. Okay, this is the first part. Now moving on to second part. So whenever you see hence in a question, it means you have to use your first part to find this answer. So in part 1 we had what? We had 5x squared minus 15x plus 1. Now watch this. What happens if I divide everything by 5? This will become x squared minus 3x plus 0.2. So this one is the same thing but divided by 5. So it means that it is also the same but divided by 5. So this one in complete square form will be x minus 1.5 square minus, so this divided by 5, that should be 2.05. So just to recap, so if you want to complete the square of this, it is equal to x minus 1.5 square minus 2.05. Now using this, we have to find what? State the least value of this and the value of x at which it occurs. So pretty easy, since you have the complete square form already. This is the least value, and this is the value at which it occurs. So we have to equate this to 0. Minus 1.5 is equal to 0. So x equal to 1.5. And this is the least value. So let's write this down. So at x equal to 1.5, the least value is equal to this one, minus 2.05. Okay, this is your answer for question number 5. Now let's move on to question number 6. So state the order of the matrix. So the order means number of rows times number of columns. So here we have 2 rows and 4 columns. So it is 2 by 4. That's the order of this matrix. Now part B, we have this matrix, find A inverse. So to find inverse, we always have to first find the determinant. So we have to cross multiply 2 times 3 minus this one, minus 1 times minus 4. That will be 6 minus 4, that will be 2. Now we have to write down what is the adjoint matrix of A. We have to switch their position. 3 goes up, 2 goes down, and switch the sign. This is 1, this becomes 4. So from this we can find A inverse pretty easily. It is 1 over determinant times this one. 3, 1, 4, 2. Okay, that is A inverse. Now for part 2 is, hence, given that we have this equation, find the matrix of B. So how would you find B? So we have to kind of play with this and see what's possible here. So A, B, A is equal to I. Okay, now how do you eliminate this one? You have to multiply by A inverse on both sides, right? So you have to get that A inverse times I. So these two will be cancelled out. You will have BA is equal to, so now A inverse times I is A inverse, right? Now to eliminate this one, you have to multiply by A inverse on the right side. That will become A inverse times A inverse. That will be B is equal to A inverse times A inverse. So let's find this. So as we know, A inverse was found in part 1 right here. It is 1 over 2 times 3, 1, 4, 2 multiplied by 1 over 2, 3, 1, 4, 2. So we can take out these two. It will be this, and then we have 3, 1, 4, 2 times 3, 1, 4, 2. So matrix multiplied by rows by column. So this time this plus this time this. So let's find out. So 3 times 3 plus 4 times 1. That will be 13. And then we have 3 times 4 plus 4 times 2. That will be 20. Then we have 1 times 3 plus 2 times 1. That will be 5. And then 1 times 4 plus 2 times 2. That will be 8. Okay, so that will be your matrix of B. You can bring this inside if you want to, but if not, that's okay as well. Okay, that will be your question number 6. Now question number 7, sorry. We have to solve this equation. So we have to find the value of x. So what's the first thing we can do here? If you observe, what is log? Log is to the base of 10. So this is log base of 10 x squared minus 3 equal to 0. So we have to send this one here. You will have x squared minus 3 is equal to 10 power 0, which is 1. Now let's solve this. X squared minus 3 is equal to 1. So x squared is equal to 4. Now x can be plus minus root of 4, which is plus minus 2. Now let's test if the value is if both value is good. So if f equal to x equal to minus 2, that will be positive and positive, so that is good. So your value of x will be plus minus 2. That is part 1. Now for part 2 is we have to show that for a is positive, we will have this maybe written as this, where k is a integer. So let's observe to see what can we do. So here we have ln a sine 2x plus 5 plus ln 1 over a. Everything you divide by ln a. Now let's look at the top first, the top, to see what can be done. So here I have a power. I can send the power in front. You will have sine 2x plus 5 ln a, right? Now how about this one? I can rewrite this as ln. We can put the a up. You will have a minus 1, which is equal to minus ln a. So it becomes minus 1 ln a. Now the next step is we can factorize this. You will have ln a will be outside. You will have sine of 2x plus 5 minus 1. That is for the top. So replace back in the fraction. The top becomes ln a sine 2x plus 5 minus 1. All this you divide by ln a. Now, as you can see, these two, this is a factorize, cancel out. You will have sine 2x plus 5 minus 1, where k is minus 1. Okay, so that is your answer for part B. Now, hence means using this value, solve this. So pretty easy. We have to find the integration of sine of 2x plus 5 minus 1 dx. That will be minus cos 2x plus 5. We have to divide by 2 and then minus x plus c. That will be your answer for part 2. That is question number 7. Now let's move on to question number 8. So in the binomial expansion of this, the coefficient of x cubed is 120 times the coefficient of x power 5. Find the possible values of a. Okay, so let's do that. So first let's try to find the coefficient of x cubed. Now, so to expand this, we have to take 6, choose something we don't know yet. The first term is a, and then this one is minus x over 2. Now, to get x power 3, we have to have power 3 over here. If this is 3, this also will be 3, and this will be 6 minus 3 is 3. So now we can simplify. 6 choose 3 is 20. A power 3 over 8. Now divide by 4, you will have 2 here, and here you will have 5. Now divide by 2, that will be 2.5. Your answer will be minus 2.5 a power 3 x cube. Now the coefficient of x cube is only this part, okay? That is part 1. Now for part 2 is the coefficient of x power 5. So the same steps. So as you can see, we have 6 here, so 6 choose something for the first term and the second term. For us to get x power 5, we have to have 5 here. If you have 5 here, this has to be 5 here. Now 6 minus 5 is 1, that will be 1 here. Now expand, you will have 6 choose 5, that is 6, times a times minus 5 over 2 power 5 is 32. Yep. Now if you simplify, divide by let's say divide by 2, you will have 16. That will be 3. So you will have minus 3a over 16x power 5. So the coefficient of x power 5 is only this part. Okay, so now we have to use this, the information that we have here, which says the coefficient of this is 120 times, so this minus 2.5 a cube is 120 times this one minus 3a over 16. Okay, now let's see what can we have. Let's solve. So let's try to divide by 4 first. You will have 4 here. Here you will have 30. Divide by 2, you will have 2, and here you will have 15. And then here you have 1. We can cross multiply, send 2 here, you will become minus 5 a cube is equal to minus 45a. So minus minus cancel out. Let's send everything to one side. You will have 5a cubed minus 45a equal to 0. Now if you factorize, you will have 5a, that will be a squared minus 9 equal to 0. So the value of a will be 0, or it can be, so we have a squared minus 9, this is also equal to a plus 3 and a minus 3. So a can be 3 or a can be minus 3. So what are the possible values of a? It can be 0, can be this or this. So that will be part 1, possible values of a. Now part B, expand this in ascending powers of x as far as this term. So we have to stop at x power 3. So let's do that. So first term will be 20, choose 0, first term. Second term, if this is 0, this has to be 0 as well, and this will be 20. Plus 20, choose 1, that will be 19, 2x, 1. 20, choose 2, that'll be 18, that'll be 2x, 2. And finally, 20, choose 3, that'll be 17, and 2x, that will be 3. Now we can simplify. You will have 1 here, plus 20, times 1 times 2x, plus, what is 10, 20, choose 2, that will be 190. That will be 4x squared. And what is 20, choose 3? That will be 1140 times 1 times 8x cubed. This will be 1 plus 40x. So 190 times 4 plus 760x squared. So 1140 times 8 plus 9120 x power 3. That will be the expansion of this until the term in x squared, x cubed, and in ascending powers of x. Simplify. As you can see here, we have this. This is part B. Now for part 2, use expansion to show that this is this correct to 2 decimal place. So basically we have to find a way to express this as this. If you observe here, we have 0.98 power 20. How can you express this as 1 plus 2x 20? So look at the inside. Let's find the value of x. So we have 1 plus 2x is equal to 0.98, which means 2x is equal to what? 0.98 minus 1. That will be minus 0.02. So x have to be minus 0.01. So we have to replace the value of x by this in this expansion. So let's do that. So you will have 0.98 square, so 20 is equal to 1 plus 40 times minus 0.01 plus 760 0.01 square plus 9120 0.01 cube. So let's solve this and see what do we get. So you have 1 plus 40 times 01 plus 760. That will be square, 0.01 square, and plus 9120 minus 0.01 power 3. That should be 0.66688. So 0.66688, but correct to 2 decimal place, that will be 0.67. This is shown as required. Okay, and that will be your question number 8. Okay, so let's move on to question number 9. So solving this equation, so how would you solve this? So you have to know your identity. So as you know, sine square x plus cos square x is equal to 1. So what is sine square x? Sine square x is equal to 1 minus cos square x. So replace this value by this. Let's see what you have. You'll have 6 times 1 minus cos square x minus 13 cos x equal to 1. Now we have to simplify. You will have 6 minus 6 cos square x minus 13 cos x equal to 1. Now let's send everything to one side to make it positive. You will have 6 cos square x plus 13 cos x. 1 minus 6 will be minus 5 equal to 0. Now let's factorize this. So what is 6? 6 is 3 times 2, so 3 cos x times 2 cos x. And 5 is just 5 times 1, so take 5 here and 1 here. Now to get minus plus 13, we have to do plus 15 minus 2. Okay, that's how you factorize these two. So you will have 3 cos x minus 1 equal to 0. So cos x is equal to 1 over 3. Now for this one, 2 cos x plus 5 is equal to 0. So cos x will be minus 5 over 2, which is minus 2.5. So since the magnitude of cos x is more than 1, so we know that cos x is only between the values of 1 and minus 1. This one is more than this, they will be invalid. So we have only one values that remain that we can use. So for this one is when cos is positive, as you guys must know by now, it has to be in your first quadrant and in your fourth quadrant. This is your value of theta. This will be 360 minus theta. So let's solve this one. So first you have to find the value of theta. Theta will be cos inverse of the positive value of 1 over 3. And this has to be in degrees, so make sure that your calculator is also in degrees. So cos inverse of 1 over 3. That will be 70.5. So now the value of x, as you can see from your quadrant, it is theta, which is 70.5, and it can be 360 minus 70.5, that should be 289.5. So you have two values for x. That is part A of the question. Now let's move on to part B. Show that for this can be written in the form of this, where a is an integer. So let's see how can you simplify this. So let's have a look at your formula sheet. So you do have a formula sheet here. Let's see what is 1 plus tan square a. So let's write this down. From your formula sheet you have 1 plus tan square y is supposed to give you sec square y. So we can replace this by this in your equation. So you will have 4 tan y over root of sec square y. That should give you 4 tan y divided by sec y. Now the next question is, what is tan y? Tan y is simply sine y over cos y. Now what is sec y? Sec y is 1 over cos y. So now we can replace. So you have 4 times tan, that will be sine y divided by cos y. Now divide by 1 over cos y. So simplify, you will have 4 sine y divided by cos y. Multiply, we can send this one, we have to flip it upside down, become cos y over 1. So just to explain again, so when you have a fraction a over b divide by c over d, we can change the divide to multiply, it will become a over b multiply. So when you have multiply, you have to flip this upside down. So this is what happened here, and these two will cancel out. That will become 4 sine y. As you can see, this can be written as this, where a is a integer, which is 4. That is part 1. Now for part 2, hence solve this equation. So as you have seen, this can become 4 sine y plus 3 is equal to 0. So sine y is equal to minus 3 over 4. Okay. Now for the values of y is negative, sorry, of sine is negative, yeah, you should know that it will be in the third quadrant. This will be pi plus theta, and this will be 2 pi minus theta if sine is negative. So first thing is to find the value of theta. Theta will be sine inverse of the positive value. So here we have to use radians, as you can see. So sine inverse of the positive value, that will be 0.848. Okay. Now for the value of y, we have to look to your quadrants. The first one will be pi plus this. So pi plus 0.848. That should be 3.989. So approximately, I would say 0.9899. We can write 99, 3SF. Okay, 3.99, and then we have this one, 2 pi minus theta 0.848. That should be 5.444, 3SF. Okay, so we have two values here, but let's see what is the range, right? So this one is pi divided by 2, so divided by 2, that should be minus 1.57 to 1.57. So here what happened here, as you can see, both values are outside the range, so you have to play with them, right? You have to make a way that we can find the values in the range. So now we can minus 2 pi from each of them. Let's see what do we get. For the first one, 2.99 minus 2 pi, that'll be minus 2.29, and this one will be 5.44 minus 2 pi. That'll be minus 0.843. Okay, so as you can see, by doing that, there's only one value which is inside the range, which is this one. So this one will be outside. So only one value will be eligible, which is this one. That is y is equal to minus 0.843. Now we can also check to see if any other values are possible. So here we have until the positive value. Let's see what can we do else. We can try to, so that's it, I think, because if you minus again, it will go more towards the negative. It will not be in the range. So that should be about it. So this is the value for which it is in the range. That is question number 9. Okay, now let's move on to question number 10. So we have to find the unit vector in this direction. So pretty easy. To find a unit vector, we first need to find the magnitude of this vector. So what is the magnitude? It is square root of 5 square plus 15 square. That should be 25 plus, what is 15 square to 25? Yep, that is correct. That should be root of 250. Okay, so unit vector in this direction will be the vector itself divided by the magnitude, 250. Now you can simplify if you want to. I guess it's for 2 points, so let's try to simplify. So what is root of this? This is equal to 25 times 10, right? Root of 25 is 5, that will be root 10 remaining. So you will have I minus 3j over 5 root 10. That will go away. So you will have I minus 3j over root 10. That could be your answer for part 1A. Now for part B, the position vectors of A and B are given by this. So here we have OA is given to you by 3 minus 5. So whenever you see position vector 2.0, it means this, okay? Now OB is given to you by this, 12, 7, respectively. Now the point C lies on AB, so we have a line AB. This is A, this is B, such that AC, so AC is twice CB. So which means AC is 2 over 3 of AB, right? Because if this is 2, this is 1, everything will be 3. So AB is 3, AC is 2. So we have this equation. We have to find OC. So now what is AB? So let's first find AB. AB, it is OB minus OA. That will be 12, 7, minus 3, minus 5. So that should give you 9, and that should give you 12. Okay, that is AB. Now what is 2/3 of AB? So 2/3 times AB, that should give you, divide by 3, that should be 3, 6, 4, that will be 8. So from here we have AC is equal to 6, 8. Now what is AC? AC is OC minus OA, which is 6, 8. So finally from that, OC will be 6, 8 plus OA, which is 6, 8 plus OA has been given to you as 3 minus 5. That should be 9, and 8 minus 5 will be 3. So your answer will be OC is 9, 3, or you can write 9I plus 3J. That is your answer for part B of question number 10. So let's move on to part 3. So part 2, sorry. Now the point D lies on OB, okay, such that OD, and this is this. We have DC is given by this. Find the value of lambda. So let's make a drawing so we can understand what's happening here. So we have the point O to B. This is OB. This is OB. Now the point D lies on OB such that, let's say it lies here. This is your point D. This is 1, and OB is lambda. So there has to be lambda minus 1 for the remaining, right? This is D. So we can form an equation here. That will be, equation that we can form here is what is, let me write this down. So we can form OD is equal to 1 over lambda OB. This is 1 and this is this. That is one equation we can write, but that's okay. As long as you understand what's happening, we can just leave this for now, and we can use this one. So DC is given to you by 6, 1.25. Now what is DC? You would say DC is OC minus OD, which is 6, 1.25. Now to find OD, we have to make OC minus 6, 1.25. Now we find OC from the first part, as you have done here. So OC is given to you by this one, 9, 3, right? So replace 9, 3 minus 6.125. That will be 9 minus 6 is 3. So 3 minus this should be what? That should be 1.75. That is your vector OD. So we know OD, we know OB, so let's write an OB. OB is given to you by the question itself. It is given by 12, 7. Okay, so the question is we have to find the value of lambda. So how would you find this value? So let's see. So we have OD is given to you by 3, 1.75 is equal to 1 over lambda 12, 7. So we just have to expand and see what is the value. So let's take the first one. You will have, so let's expand more. You will have 3, 1.75 is equal to, let's bring this one inside. You will have 12 over lambda, 7 over lambda. So we compare. 3 is equal to 12 over lambda. So from this you will have lambda is equal to 12 divided by 3. That will be 4. That's the first value that we have. Okay, let's see if that is true for this one. So here we have 1.75 is equal to 7 over lambda, which means lambda is 7 divided by 1.75. Let's see if that is true. That is same value. So we confirm that lambda is given by 4. And that is your answer for part 2 of question part B. That is question number 10. Now let's move on to question number 11. So let's see what do we have here. So the velocity v of a particle traveling in a straight line is given by this equation. So we can rewrite this as what? As 4t plus 1 minus 3. Now, explain why the direction of motion of the particle never changes. So as you can see, because why? Because the value of t is always positive. If this is positive, this base will always be positive, and this value will be positive. So if this is positive, this plus this cube has to be positive, which means the value of v has to be positive as well. So that's why the direction, we means the direction here means what? Direction in this case, it means the sign of your equation. The plus or minus sign of the equation will never change. This is what it means. It will always be positive. That's why it never changed. Okay. Now for part 2, showing all your work, find the acceleration at this. So as you know already, a is equal to dv by dt. So we know v already. We can find dv by dt. That will be 4 is only the multiple. We have to first multiply it by the power, so minus 3 t plus 1. We have to minus 1 on the power, that will be minus 4. Then multiply by the differentiation of the inside, that is only 1. You will have minus 12 over t plus 1 power 4. Now you have to find this value at when t is equal to 5. So replace this in here. You will have minus 12 over 5 plus 1 is 6 power 4. So minus 12 divided by 6 power 4. That should be minus 1 over 108. And that will be in terms of meters per second square. That is your answer for part 2. That is your acceleration A at time t equal to 5. Now for part 3 is find an expression for the displacement of the particle. So to find x, we have to integrate your v. That will be v is given to you by 4t plus 1 minus 3 dt. So let's do that. 4 is only a multiple. We can leave this alone outside. Then we have to plus 1 to the power. So that becomes minus 2. Then divided by minus 2 divided by the differentiation of the inside, that is only 1. Now plus c, that is v. Sorry, this is x, not v, x. Now as you know, when time is equal to 0, x has to be 0. So replace and see what value of c do we get. So when x is 0, when t is equal to 0, t is 0, that will be 1 minus 2 plus c. So this will be giving you c will become, so that is this becomes 1, right? And this becomes minus 2. So c is 2. So finally x is given by 2 minus 2 over t plus 1 square. That is your expression for the displacement after t seconds. Okay. Now for part 4, find the distance traveled by the particle in the 4th second. So the 4th second is what? The 4th second is the time between the 3rd to 4. So let's find this and this. So let's find the value of x when t is equal to 3. That will be 2 minus 2 over, that will be 4 square. And find x when t is equal to 4. 2 minus 2 over 5 power 2. Let's see what values do we get. 2 minus 2 over 16. That's the first one. And we have 2 minus 2 over 25. That'll be 123 over 25. So we have to minus those two to find the distance traveled. Minus 1 over 7 over 8, that should be 9 over 200 meters. If you convert this to decimal, that should be 0.045. Or you can write 0.045 meters. Okay, that is your question 11. Okay, so let's move on to question number 12. The functions f and g are defined by this for this domain and this for this domain. Now, part 1, state the range of this one. It is only for 1 mark. So pretty easy. Let's assume that the value of x is 0. What is the value of g of 0? That will be minus 9. So the range of g will be g is more than minus 9. The reason why we don't write equal to is because here we don't have equal. That will be your range. Now for part 2, find the domain of g of f. Now, to find this, we have to look at both of their domain separately. So for the first one, let's look at f. F is more than 1. Let's say this is 1. Okay? This is more than 1, for example. Right? Now we look at g. G is more than 0. 0 will be before 1. That will be 0. That will be more than 0. So these two, where they meet only here, which means that the domain has to be more than 1. That will be part 2. Now for part 3, show all your working, find the exact solutions of this. So let's find that. So first we have g of x is g of f of x. That is equal to 4 f of x square minus 9. That is 4 times 5x minus 2 square minus 9 is equal to 4. So simplify, you will have 5x minus 2 square. That should be 13. So 4 plus 9 will be 13 divided by 4. Now next step is 5x minus 2 is plus minus root of 13 over 4. That is plus minus root of 13 over 2. Now x is what? So we have x can equal to, so 2 plus minus 13 over 2 divided by 5. That could be the value of x. So here we have two values of x. X can be 2 plus root of 13 over 2 divided by 5, or it can be minus root of 13 divided by 2 over 5. So here we have a condition where x has to be more than 1. So let's see which one is more than 1. So let's test this one. You will have 2 plus, so let's say root of 13 divided by 2 plus 2 divided by 5. It is 0.7605. How about this one? 2 minus, so that's the root of 13 divided by 2. 2 minus answer divided by 5. That is 0.0394. So you can see both are less than this, so neither will be the answer. The reason why, after checking the marking scheme, they have made a mistake in this question, because in the marking scheme this is supposed to be equal to 45. So by using this you will find the correct answer, but for this question itself we don't have any answer for this domain. So we don't have any answer. But the actual question had to be this one, equal to 45 according to the marking scheme. Using this you will have to find an answer. But for this one, these two answers will not be valid. Now let's move on to the last part of this question. So here we have the function h is defined by this, right? Now state the geometrical relationship between this and this. So you have to know every time whenever you have a function and the inverse of the same function, their relationship is always going to be, you guys must know this by now, it is always going to be a reflection in the line y equal to x. It will be always the case between a function and its inverse, that will be their relationship. Now for part 2, find h inverse. So first step is to let y equal to h of x, which is this. Then that will be so y squared equal to x squared minus 1. We have to make x become the subject of formula. You will have plus 1. H will be plus minus root of y squared plus 1. So as you can see, it is in terms of x. We have to express this in terms of x. That will be plus minus plus 1. Now you go back to here, you can see it has to be less than 1. So here has to be negative. Negative x squared plus 1. So that will be your answer for part 2 of question part B. So that was the last question of this paper. As always, thank you for watching. And if you guys have any questions, don't forget to leave a comment below. I will get back to you guys as soon as possible. And please do like this video and subscribe for more videos in the future. And thank you for watching. I will see you soon.